Hi everybody, and welcome to this presentation about LoRa 2.4. My name is Pettersen. I'm the founder and the CTO of Vicotee. So today I'm going to talk about our experience with LoRa 2.4 and how we can move forward with that. First of all, I want to show you a map. This is a snapshot from marine traffic. And as you can see, there is a lot of boats and ships crossing the seven seas, going from Europe to Asia to the States. The problem here, if you're using standard frequencies like 868 or 915, and you go from Europe to the States, you'll actually need to change your frequency from 868 to 915. It's doable, but it's not that elegant, and it's a little bit hard to do it because you have to be sure that all of your devices is now running on 915. With the introduction of LoRa 2.4, you don't have to think about this anymore because you have the 2.4 gigahertz, and that you can use everywhere. And that was a game changer for us because now you can monitor your assets everywhere in the world. You can do monitoring and condition monitoring on ships going worldwide without considering the frequency. And you also have the same range because the 2.4 has been available for a long time with the Bluetooth and Wi-Fi. The problem there, especially if you're going to monitor your assets or do monitoring on ships, you need the long-range devices, and that you also have with the LoRa 2.4. A couple of years ago, we were invited into a project with Wilhelmsen and Semtech. And the purpose of this project was to bring LoRa to the sea. And of course, that was a very exciting project for us to be a part of. And as you can see on this picture, this ship is huge and it's bare metal. So, bringing in radio technology on that ship and see if we can have full coverage, I was thinking this is going to be hard. So what we did, we put 2 gateways on the bridge and 1 in the engine room. And then we went all over the ships, all the decks, all the rooms, everywhere, and measure to see if we have radio coverage there. And we did. So that was fantastic. So now we knew that with the LoRa 2.4, we had full coverage on the ships with 3 gateways. And this is LoRa 2.4, so this ship can go everywhere in the world. And it also does, it goes everywhere. So these pictures were taken during the installation on the ship. On the picture to the left, you can see the harbor in the background. And you can also see the assets. Imagine that all these assets have a LoRa 2.4 device in them. That means that you can track all these assets. You know that if they are left on the harbor or if they have entered the ship. And if they're going from Europe, the assets come into the boat in Europe and you leave it in the States, again, you need to have the 2.4. You cannot go with the 868 or 915 here. So with the LoRa 2.4, you're good to go. So another project that we're doing together at Wilhelmsen is a smart rope. So these sensors are to be installed inside of the ropes and they are measuring the tension. So these sensors, they are actually equipped with both Bluetooth and LoRa 2.4. The reason for that is there is a lot of ships that have Bluetooth available and other ships, they have LoRa 2.4. But again, it's the same. These ropes, they are used in Europe, they're used in China, they're used in the States. Therefore, it's important to have this 2.4 frequency. Okay, moving from the sea and down to mines and tunnels. And this is actually pretty similar to what you have on the sea and these big ships, because the environment is pretty rough. We have this a lot of concrete, metal, so you need a radio that can handle these conditions. Also around mines and tunnels, you have a lot of assets. So being able to track them, you will need a long-range radio. On this project, as you can see on this picture, you will see a big fan, and this fan is blowing fresh air into the tunnels and mines. So what we are doing here, we have sensors inside of this tube, measuring that fresh air is coming in and also that the pressure is where it should be. But what's important then is to be 100% sure that the signal, if something happens, that the signal will reach the gateway. If not, it can be very, very dangerous because they are lacking of fresh air. So this fresh air system is actually been moved from Europe to the States, to Asia, to Africa, everywhere. So our customer, they wanted to have a standardized version. So they wanted to have sensors pre-installed in this tube and in the fans, and so that they could ship it everywhere. And again, with the 2.4, you can do that. And you are sure that the signal is so stable that you will get these warnings when something happens inside of the tunnel. Bringing condition monitoring to a new level. How can we leverage the power of the LoRa 2.4 with condition monitoring devices? There's a lot of challenges doing wireless condition monitoring, and one of them is, of course, the battery life. When you have installed hundreds of devices, you really don't want to go around changing batteries every 3 months. Another thing is that you need to have the on-premise backend server that will collect the data and do the analysis. And you will need the know-how. You need to know how the machinery works, you need to know the frequency, you need to know what you're looking for. So these sensors, they are producing tons of data. And LoRa isn't optimized for streaming data like Bluetooth and Wi-Fi. Another thing is, again, is the range. When you have, for example, on a ship and you do condition monitoring on these big ships, you will need the range or else you will need a lot of gateways. So how can we handle these challenges? What we have done is that we have put all intelligence inside of our device. We don't have the know-how. We don't know how this engine works or that engine works. We don't know what to look for there. But a lot of other companies that are specialists in condition monitoring and know the machinery, they know. So what we have enabled for them is to put their algorithms down to our devices. That means that our devices is constantly doing the measurements. The data is going through their algorithm, and it will just send you a warning when something is about to happen. And if something happens, then it can start to stream the data to the cloud. If the battery then dies, then it's no problem because you have an incident and you need to figure that out. So doing it this way, we can leverage the power of the LoRa 2.4. You have the range and you have the robustness. So here are the sensors installed on machinery, and they can stay there for approximately 5 years running on these batteries. The only thing these devices is sending to the backend system is just a heartbeat, once a day, once a week, saying everything is okay. But when something happens, it will raise a flag and it will send over a data set so they can do more thorough analytics on them. So a summary of this presentation. The LoRa 2.4 can be used everywhere. It has a low power consumption, it's a robust radio, and it has a decent range. I've been talking a lot about the LoRa 2.4 in this presentation, but there is also a lot of other good radios that you can use because the LoRa 2.4 cannot handle all the application that's out there. That's why I was very glad when I saw that Vicotee had a post on LinkedIn last week. He's a believer of using the right radio for the specific use case. For example, streaming audio, then you use Bluetooth. And if you're in a part of the country that don't have LoRa coverage, then maybe narrowband have coverage. So it's very important to think, okay, what radio to use on this specific case. Because like Vicotee said, let's build this thing together. That's what's important right now. Thank you very much.